Our project is about identifying fake images and videos circulating around the social media with malicious intent to harm others' reputation or mislead the public using two main approaches: deepfake glitch detection and context analysis.
I'm going to talk about how feature extraction can be used to determine whether the video is real or fake. A video can be represented as a four-dimensional tensor composed of frames, and each frame can be passed through the autoencoder. The autoencoder compresses the image into a vector of size 30, representing 30 features in a latent space, and we can stack these vectors and form a spectrogram. And now we used another neural network called convolutional neural network to see signs of deepfake spectrograms. And this was the output from the training. And now we can look at the neural network here. This is the definition of the neural network. And then I've gone through the training here. And then you can see the results of the training in the graph below. And so x-axis is the epoch, and then the y-axis is the loss score. Then, using the autoencoder, we can train our convolutional neural network, as I've mentioned earlier. You load the autoencoder that we have trained in a previous notebook, and then we define the feature extractor class, and, and we also define our data set, and then we do the training. So once the training is done, we also feed the neural network unseen videos. And then we generate the confusion matrix to validate its performance.
We have used this notebook for the context analysis part of our project. We use the masked RCNN model for the semantic segmentation. Here we use the COCO data model to identify the different objects in the image by drawing up bounding boxes around them. Then we use the AWS recognition to recognize the celebrities in the given image. Here we can see it recognized both JLo and Shakira. After using the results from the AWS recognition, we pass the image through the LSTM model that converts the image into a caption. So here we can see it converts the caption for this image as a man is playing with a soccer ball. Then we use the Roberta transformer, which is used to insert the person's name into the generated caption. After using Roberta, we fed our query to these third-party APIs to get the similar articles related to the image. Here, our output includes the title, publish date, URL, and the description of the articles. So, using these APIs here, we can see that it published articles related to the JLo and Shakira.
Knowledge graphs are derived from the results obtained from the APIs. Knowledge graphs are used to deal with interconnected entities such as people, organization, places, events, etc. Entities are nothing but the nodes, and the nodes are connected via edges. We have built the knowledge graph using the popular SpaCy library. Later, we have calculated the similarity score between every other sentence obtained from the above APIs. Further, the sentences are clustered or bucketed based on the similarity score and the knowledge graph results.
So with our knowledge graph, we can get more information out of it. And to analyze the knowledge graph, we use the transformer, and we defined our transformer dataset as well as the encoder and decoder architecture to process the events. And we used it to fact check and also predict the future events. So we explored the two approaches. One is deepfake glitch detection and the context analysis. And we came to a realization that the same problem can have a very different approaches. So we definitely learned a lot from it. And we hope to see a lot of progress in this area as it has a lot of impact in our social media today.